Hi everyone, this is Ashley Bedford with the Runtime Diaries. I am super excited. It is day 10. We have a fun one here, group anagrams on the hashtag 30 Days of Code Challenge with Educative. I won't hold you any longer. Let's get into it. Group anagrams is one of the most common interview problems that looks simple on the surface, but teaches you a lot about hashing, normalization, and algorithmic thinking. So let's start with what this problem is actually asking. We're given an array of strings, and we need to group together all strings that are anagrams of each other. An anagram just means two words use the same exact letters with the same exact frequencies. And order does not matter. So if two words look different, but their letters match, they belong in the same group. And our job is to return all those groups. This problem is actually more important than people realize. It looks like a cute string problem, but it tests real interview fundamentals. You're being tested on three things: hashing, string normalization, and frequency counting. These are patterns used in real systems. Anytime you normalize data and map it to buckets, you're basically doing what this problem is asking. Even though it's simple, the underlying pattern is powerful. Let's look at a real example. If the input is from left to right in the array, eat, tea, tan, ate, nat, bat, your output would be groups like from left to right in the array. Here's group 1, eat, tea, ate, group 2 from left to right, tan, nat, and group 3 from left to right, bat. You're grouping based purely on the letters and not the order. Edge cases matter here too. Empty strings, single letter words, very long strings, or repeated words. These all still follow the same rule: match letters and frequencies. Most people's first instinct is to sort each word. Why? Because if two words are anagrams, once sorted, they become identical. So, for example, eat becomes AET, and tea becomes AET as well. So now you have a stable key to group on. Sorting is the easiest mental model to start with. So the naive plan is simple. For every word, sort it, use that sorted string as the key, put the original word into a hash map under that key. By the end, your hash map values become your groups. This approach works. It's readable, and it's perfectly fine for small inputs. But let's note that sorting is expensive. If each word has length capital L, then sorting costs L log L time, and you do that for all in words. So your time complexity is N times L log L. The space is proportional to the number of characters across all words. It works, but it's not optimal if your words get long. And this is the moment where we shift from beginner intuition to more advanced thinking. Instead of sorting letters, what if we just counted them? Every word can be described by the frequency of each letter A through Z. For example, eat becomes 1E, 1A, 1T, and 0 of everything else. And if another word has the exact same counts, it is an anagram. So now, instead of sorting, we create a 26-length frequency list, convert it to a tuple, and use that as our key. This eliminates sorting completely. The flow becomes: make a list of 26 zeros, increment counts for each letter in the word, turn that list into a tuple, use it as a stable hash map key, append the word into that list. This runs in pure linear time for each word because counting letters is O of L. So now our space complexity is N times L. There's no sorting here, and we're only counting. This is the most optimal way to group anagrams because there's no way to avoid touching every character. That is your lower bound. So which approach should you choose? If you're in an interview and you want the fastest approach, definitely use the frequency counter. If you want the simplest, shortest code, the sorting version is easier to write and easier to read. Both work. One is simpler, one is faster. Here's the naive sorting version. It's clean, very readable, but slightly slower. And here is the optimized version using a frequency tuple. This is the version I would personally use in interviews when performance matters. So the big picture is, anagrams are really about normalization. Either sort the letters or count the letters. Hash the normalized form. Group the letters. This pattern shows up in many problems, not just anagrams. And that's a wrap for day 10 of our hashtag 30 days of code challenge with Educative. If you like this video, like it down below, subscribe to our channel, share this video with a friend. We would love to have you here, and we are going to be bringing a lot more of these breakdowns very soon. So we will see you next time.